force will be 12 Newton minus the friction, right?
Mm-hmm.
You got this? And then this force will be ma. The resultant force cause acceleration is ma, right? F equal to ma.
Okay, so then you solve for A?
Yeah, because you know everything. The only thing you need to calculate is A. If you solve it, it's 2.04.
Okay, and then you do the rate?
Yeah. Because it's the work done by this P, okay, at T times 2 seconds. We know it starts from at the rest. At the beginning, the velocity was 0. So when T equal to 2 seconds, velocity will be AT, which is 4.08 meter per second. So the rate at this time point will be T times weight. P is 12 Newton times 4.08. So it's 48.96. The answer will be B. Okay. Number 15, I don't have the figure. I don't know how is the figure. So we cannot do this question. 15. The figure is missing.
Is there a way that you could...
No, I can imagine it's something like this. There is a spring and something like this, an object. But I don't know this angle. We need to know that to be able to calculate. But there are similar questions.
Okay, we can keep going.
Yeah.
Tomorrow I'll tell you. So what do we need to answer? 15?
15, we need a graph. So, because it's here, as shown, but there's no graph.
Okay.
We need one graph. And then ask number 8. The answer is not correct. Okay. Number 16. So this question, we know an object move along x, and the initial velocity was 4, and that's the only force acting on the object. Excuse me. What's the energy at x equal to 3? At here, this point, what's the energy? this energy will be equal to the initial energy plus the work done by this force, right? Because the energy is equal always. So we know the initial velocity. That's the initial kinetic energy. And the work is the force times the distance, right? So you need to calculate the area here. Just remember here is negative because it's below x. It's in the different direction. Here is 8. Here is 2. So it's 1/2 times 2 times 8 minus this negative thing. Here is 1. Here is 4. So it's 1/2 times 1.5 times 4 squared plus 8 plus 2 minus 2. You calculate here is 3 plus 8 minus 2, which is not 3. Here is 4 square. Square is 16, so it's 12. So it's 18. Have any questions?
No. But where's the answer here?
18. A. Answer. 18.
Oh, we on number 8. Oh.
Yeah.
I don't know, I was looking at number 16.
All the answers?
Okay, so it goes from where it go from? From 1 to 2 in a positive?
From 0 to 2 is positive.
From 0 to 2,
From 2 to 3
and
is
then like 2
negative.
to 3.
Yeah.
So it'd be
So
1.
that, yeah. So here is 2, 8. Here is 1, 4, right? You just need to calculate the area,
Okay, I get it.
which is the work.
Next page.
The only force acting on a 2-kilogram body moving along the x-axis, the force is 2x Newton. If the initial velocity is 3 meters per second, how fast it moves at x equal to 2 meters. So, it's the same thing, we need to something like this. So here is fx, here is x. And we need to, from 0 to 2, like this, we need to calculate the area here. Okay? So how you do it is the kinetic energy at 2 meters should be equal to the initial one plus the work done by this force during this 2 meters, right? This one will be 1/2 m velocity at the end square. This one is 1/2 and velocity at the beginning. And the work is 0 to 2 fx dx, because you need the area here.
Couldn't we just take the integral of 2x, so it'd be 2x squared over 2? So it'd be x squared?
X squared, yeah. So when you calculate, here is x squared, 0 to 2. So you just need